Hello everyone. In the last session for data warehousing and data mining course, we saw about efficient data cube computation. What is a data cube? Data cube is a lattice of cuboids. Suppose you are having a warehouse having n dimensions. There can be 2 raised to n cuboids defined by using dimensions at different levels of abstraction. So when you are having so many cuboids at different levels, including the base cuboid and the apex cuboid. What is base cuboid? Base cuboid is a cuboid at the lowest level of summarization, which includes all dimensions, and apex cuboid is a cuboid at the highest level of summarization, which includes 0 dimension. So when you are having so many cuboids at different levels of abstraction, you can have queries which can be mapped to each level. You can have 0 dimensional query which will not be having any group by clause. You can have 1 dimensional query which will be having 1 group by clause. You can have n dimensional operation or query which can have n group by clauses. Now, when it comes to multiple cuboids, you can pre-compute the values of these cuboids. But what is the advantage of this approach? You will get response fastly. But what is the disadvantage here? Here there will be a lot of storage space wastage. For n dimension, you can have 2 raised to n cuboids. So when you are pre-computing the values of all these 2 raised to n cuboids, it will be a wastage of storage space. The situation becomes more complex when the dimensions are having concept hierarchy. If suppose each dimension is associated with multiple levels in the concept hierarchy, more storage space is wasted. So either you can have full materialization where you will pre-compute the values of all the cuboids, or you can have no materialization where you will not pre-compute any of the values, or you can have partial materialization which pre-computes the value of a few of the cuboids. Those cuboids will be selected as per certain criteria. With this, let us go to today's session. Today we'll be seeing about indexing of OLAP data. So you can have 2 types of indexes for OLAP data. First is the Bitmap Index and the second is the Join Index. Let's first see what is Bitmap Index. So Bitmap Index is done by indexing on a particular column. Each value in the column has a bit vector associated with it. So length of the bit vector corresponds to number of records in that particular column. Okay. So here there is a significant reduction in storage space as string of characters are represented by a single bit. So let's see the example given here. So I have the base table here. I have customer, region and type. Customer, there are 5 customers, C1, C2, C3, C4 and C5. I have defined an index on region and another index on type. How do I define? First of all, I should see the column, this region column I should see. How many values I have here? I have a value Asia, I have another value Europe, and I have another value America. Okay, so for each value I'll be representing by a bit. Can you see here? Asia, Europe, America. So we are representing each record. When we index on region, we are representing each record by 3 bits. Why 3 bits? Because there are 3 values for region, 3 distinct values for region: Asia, Europe and America. So index on region will be represented by 3 bits. Now consider the first column, record ID 1. For the first column, the value for region is what? It is Asia. So bit for Asia, bit representing Asia is set to 1 and bit representing Europe and America is set to 0. Consider the second column. For second column, the region value is Europe. Okay, so the bit representing Asia and America is set to 0 and the bit representing Europe is set to 1. Okay, now for record ID 3, the value for region is Asia. So if you see here on the index, for Asia, the bit representing Asia is set to 1 and the bits representing Europe and America is set to 0. Coming to the next record, the region value is America. So bits representing Asia and Europe is set to 0 and the bit representing America is set to 1. Okay, so this is how you define index on region. Now coming to index on type. So we will first go to the column type. We will see how many distinct values are there. How many distinct values are there? 2 distinct values, retail and dealer. So we'll be representing each record by 2 bits. Okay. So here retail, dealer. Now coming to the first record, what is the value for type? The value for type is retail. So the corresponding bit, that is retail bit, is set to 1 and dealer bit is set to 0. Consider the second record. The value for type is dealer. So the bit representing dealer is set to 1 and the other bit is set to 0. So this is how we define index or bitmap index for the OLAP data. What is the advantage here? Instead of representing as Asia, Europe, see here for C1 I have mentioned Asia. Again for C3 also I have mentioned Asia. So I am doing redundant data storage. Again and again I am mentioning Asia as full string of character. But here what I am doing, I am using a single bit to represent my data value. So that means there is a significant reduction in storage space as a string of characters. The whole Asia, that's a string of character, is represented by a single bit over here. Okay, so there will be a significant reduction of storage space, especially when there are repeated values for each column. There are multiple records having the same value for region. There are multiple records having the same value for type. In that case, bitmap indexing will be advantageous. So this is bitmap indexing. But what is bitmap indexing? Here, index will be formed based on a particular column. Okay, each value in the column will be associated with a bit vector. The length of the bit vector depends on the number of values for that particular column, and the bit corresponding to that particular value is set to 1 and the other bits are set to 0. Okay, so when you consider region, index on region, if I consider the third record, the value is Asia. So bit corresponding to Asia is set to 1 and bits corresponding to Europe and America is set to 0. When you consider the index on type, you have only 2 distinct values, that is retail and dealer. So you can store each record by using 2 bits. Okay, so retail and dealer. The first record C1, type is retail. So the bit representing retail is set to 1 and the bit representing dealer is set to 0. Okay, so this is how you do bitmap indexing. Next is join indices. So in data warehouses, join index relates the value of the dimensions of a star schema to the rows in the fact table. Consider the example given here. You have the fact table, that is the sales fact table. You have multiple rows with some ID, T57, T238. I have mentioned some IDs for the rows in my sales fact table. I have a location dimension table and item dimension table. I hope you have by now understood what is a dimension and what is a fact. A dimension is used for representing the record, and fact relates the dimension or connects the dimensions together. Okay, so now consider the dimension location for a particular value, that is Main Street. It is associated with 3 rows of the sales fact table. 3 IDs it is connected to. If you consider the item Sony TV, two rows in the sales fact table it is related to. Okay, so based on this relation, we will be forming the join index. So here fact table is the sales fact table, two dimensions, city and product. A join index on city maintains for each distinct city a list of record IDs of the two tuples recording the sales in the city. So for Main Street, the set of record IDs are T57, T238 and T884. Okay. For the item Sony TV, the record IDs are T57 and T459. This is how you form the join indices. So here we have shown in detail the example. See here, same example. Location, item are the dimension table. Sales is the fact table. So Main Street is associated with record IDs T57, T238 and T884. Sony TV, item Sony TV is related to T57 and T459. Now, when I form a join index for table based on location and sales, you can see Main Street is associated with T57, Main Street is associated with T238 and Main Street is associated with T884. Okay, as per mentioned. Now, when I'm forming a join index table for item and sales, okay, so Sony TV is associated with T57 and T459. At the next level, when I'm forming a join index table, linking location, item to sales fact table. So I'm combining all these together. I'm linking location and item to the fact table sales. Okay, in that case, what do I get? Main Street, Sony TV, T57. That is the common value. When I perform a join operation, I'll get the result as Main Street, T57, Sony TV. Because main T57, the record ID T57 is associated with Main Street. Also, the record ID T57 is associated with Sony TV. So when I do a join operation, I'll get the result as Main Street, Sony TV, T57. So this is how we define a join index. So these are the two ways of indexing OLAP data. One is join index and other is the bitmap index. So bitmap index depends on the number of values belonging to a particular column. A bitmap is shown with the number of bits which is equivalent to the number of distinct values in the column. Okay, and for each record ID, the bit representing that particular value will be set to 1 and the other values will be set to 0. In case of join index, we will try to join the dimension table and the fact table. We'll try to relate the dimension table and fact table. Based on the join operation obtained, you can combine multiple dimension tables as well. Okay. Next is data generalization. From the word itself, generalization means summarizing. Okay. So data generalization basically summarizes data. Summarization of data can be either done by dimensionality reduction or by using concept hierarchy. So what is dimensionality reduction? Already we have seen this. What is dimensionality reduction? Remove certain dimensions. For example, if you are having a student database and you want to analyze the behavior pattern of students. Okay, so when you are analyzing the behavior pattern of students, you need not have telephone numbers or email IDs for the relevant data, right? So I can remove the dimensions representing telephone number, email ID, date of birth, etc. So that is an example of dimensionality reduction. I repeat this example. If suppose you are having a database of students and you want to analyze the behavior pattern of students. So when you are analyzing the behavior pattern of students, the dimensions like the telephone number or date of birth or email ID is not at all relevant over there because you are analyzing the behavior pattern. So you can remove those dimensions. That is called as dimensionality reduction. So basically you are summarizing the data by removing some dimensions. The second is replace the lower level values with higher level concept. Okay. For example, if suppose you are having a dimension age, Okay, for age at the lower level you can have specific values for each person. Suppose one person 1 maybe age will be 10 years, person 2 the age will be 20 years, person 3 the age may be 22 years. You can have specific value as age of each person. Okay, another person can have age as 60 years also. Okay, so you can have specific values when you are when you are specifying the data, when you are having a specialization of the data, or when you are having a detailed data, you will be having specific lower level values for that particular dimension. Now you can generalize this data to higher level concept. For example, as age is concerned, you can group it as young, middle-aged and senior. Okay, so a person who is having a range of age from 1 to maybe 18 years, we can put it as young, and from 18 years to maybe 50 years we can put it as middle-aged, and above 50 years we can put it as senior, right? So likewise we can group the age. This is also a way of summarizing the data or generalizing the data. So mainly two ways of summarizing the data. Which are the two ways? Dimensionality reduction and using the concept hierarchy or grouping. You can replace lower level values with higher level concept. Okay, so related to data generalization, we will be learning attribute oriented induction. How to do data generalization using attribute oriented induction in the next class. Thank you.